Software systems can be enormously complex. The complexity increases when multiple software systems are interconnected or when the product also includes hardware components. One way people deal with complexity is through abstraction. Abstraction allows us to present information at varying levels of detail depending on how much information any particular audience needs and can handle at some point in time. Visual analysis models provide a powerful set of tools that let business analysts depict system information at various levels of abstraction. These models serve as an aid to understanding as well as an aid to communicating. Unfortunately, I fear that modeling is somewhat of a neglected practice. I believe modeling is an essential skill every business analyst should master. Here is why. Simple diagrams like flowcharts had already been around for years. The early structured analysis models included the context diagram, data flow diagram, entity relationship diagram, and state transition diagram. Those are still useful and relevant with today's systems. For instance, every system can benefit from a context diagram. Before long, dedicated software tools came along that made it easy to draw and modify diagrams using those standard notations. The later unified modeling language supplied numerous additional models that are useful for systems analysis. I found the models helpful both for understanding the problem domain and exploring solution approaches. They're also valuable communication tools, helping to bridge the gap between customers with needs, analysts who must understand the problem and conceive solutions, developers who build solutions, and testers who verify those solutions. While using visual modeling approaches on all of my projects, I learned an important lesson early on when I tried to find a single diagram that would depict all the important information about a system. There isn't one. Each analysis model provides one view of the requirements, as do a written requirements list, tables, user stories, acceptance tests, prototypes, and countless other ways to represent information. Another important lesson I learned is that we should use existing standard modeling notations whenever possible rather than inventing our own. Models, like all requirements representation techniques, are communication aids. We can only communicate effectively if we all speak the same language and understand the notations. If you invent new symbols, arrow styles, or other conventions you find convenient, the people who read your diagrams might not understand what you are trying to say. That only leads to confusion, not to effective communication. One big benefit of modeling was the ability to easily revise the diagrams as problem understanding and solution concepts evolved. Such iteration is a foundation of successful software engineering. It's far faster and cheaper to iterate on high-level diagrams than on code. A strong argument for modeling is that representing knowledge in different ways allows you to compare those alternative views to look for gaps and disconnects. They show you information in different ways, but the models all must agree. By creating these multiple views, you can detect such errors and quickly correct them early in the process before anyone has written the code. This helps prevent more expensive rework later on. If you're a business analyst, tune up your skills in the modeling arena and add a wide variety of models to your BA toolkit. Be prepared to explain the notations you use and why you drew the pictures to your peers and customers who aren't familiar with them. You're not going to get a diagram right the first time you sketch it out, so look for tools that make it easy to draw the models you find the most helpful and to iterate on them. One would argue, our system is too complex to model, but think about it for a moment. By definition, a model is simpler than the thing it's modeling. If you can't handle the complexity of the model, how can you expect to handle the complexity of the problem? Visual models can certainly become complex and confusing for complex and confusing systems. But that very challenge is a good argument for doing the modeling, to get a handle on that complexity before it bogs you down during construction. You don't necessarily need to model the entire problem or solution space. Focus your modeling effort on the most complex, most poorly understood or riskiest parts to make sure the project stakeholders have a clear, shared understanding of what you're trying to build. Business analysts sometimes push back against the idea of modeling. I don't have time, they say. Certainly, you should only perform activities that add value to the project. Some activities add immediate value, others add value down the road. Taking the time to model business processes and system requirements is an upfront investment that can pay off in multiple ways. It's certainly worth thinking about whether creating models will save time either during development or post-delivery. If you decide it won't, don't do it. But as with so many aspects of software quality, it's not a matter of you can pay now or you can pay later, it's you can pay now or you can pay a great deal more later. The old adage says, a picture is worth 1,000 words. Software people know it's actually a bit better than that. A picture is worth 1,024 words, at least.
SmartApps.cz